Okay, in section 8.1 we're going to start our study of what we call conic sections. Ultimately, when we have two right circular cones that are point to point with one another, and we slice the cone with different planes, we generate what we call conic sections. So, here are a few of the conic sections that we're going to study most specifically in this class, which are ellipses, parabolas, and hyperbolas. If we slice one of the cones with a plane that doesn't go straight straight horizontal, okay, we're going to get an oval shape, which we call in math an ellipse. Okay, if we were to slice the cone, as you can see here, we get a parabola, which we have quite a bit of experience with. We're going to look at it from a little different standpoint today. And then also when we slice the cone straight up and down, we get this curve that's two separate curves, but it's all one equation. We call that a hyperbola. Now there are other, what we call degenerate conic sections. When we do other slices with the planes, and here are the pictures for those. If we were to slice right at the point of intersection, we get a point. Of course, the only intersection between the cones and that plane would be that point in question. We could get, if we run the plane in this angle, we're going to get one line. The line would be the intersection point between the two cones that is, and the plane. And then also if we go straight up and down through the vertex point, if you will, we're going to get two intersecting lines, and that would be the intersection between the cones and the plane. Now, in general, when we talk about conic sections, okay, we're discussing what we call second-degree equations in two variables. Okay, those are going to be equations for conic sections. Okay, they can be defined algebraically as that. Notice we have two variables here, x and y. Okay, we're going to have an x squared and a y squared. Okay, in some cases, the x squared or y squared, the c or a might be 0, and in that case we would only have either x squared or y squared, and that's going to be the case for a parabola. As we know, that's the one we have the most experience with. And also a, b, and c cannot be all 0. If all three of these parts were 0, then we would be left with this, which is just a linear equation, which is not a conic section. Okay, so let's start by talking about parabolas. We're going to focus on those today. A parabola is a set of all points in a plane equidistant from a particular line, which we call a directrix, okay, and a particular point, a focus. So if we have the focus here and this line, the directrix, okay, every point that's on the parabola is going to be the same distance from the focus to the directrix. So that point, if we were to calculate the distance from the point to the focus and the point to the directrix, those two distances would be the same. If I picked a point out here and I drew a line from the focus to that point and the directrix to that point, okay, we would have equality in terms of the lengths of those two segments that I would draw. Alright, so like I said, from our work before, this is a little different standpoint. Looking at a parabola, it still has the same properties that we studied in the previous parts. But what we're going to focus on today is how is it related to the focus and the directrix in terms of the equation and the graph, etc. You'll notice also that the vertex is the line, is the point that's right halfway between the focus and the directrix if we go on a perpendicular line from the focus to the directrix. Okay? So what we're going to look at today is if we have equations that are of the form x squared, if we have x squared and not y, y is not squared, notice. If we have them of that form, we can also think of this as 1 over 4p x squared equals y. So in either capacity, if we write it like that, and we recognize that that looks more like a quadratic equation that we've studied in the past where we have y equals something x squared. Okay? If that's the case, we have a couple things that are going to always be true if it's in that form. The vertex is always going to be at the origin. Okay? The value of 1 over 4p, if it's positive, it's going to be this version where we have one that opens up. If it's negative, it opens down, of course. Okay? The focus is always going to be at the point 0p if it opens up or down. And the directrix, of course, is going to be y equals the opposite of p. Okay? It's going to put the directrix above. And keep in mind the vertex has to be between the focus and the directrix. The focus is always inside the parabola with whichever version we're looking at. The directrix is always on the outside, if you will, thinking of the inside as this part. Okay? All right. So, a couple of key facts here dealing with the parabolas that have a vertex of 0, 0. This is the one that we just looked at. Okay, we open up or down, we know. The focus is always at 0p. The directrix is always y equals negative p. Notice it's a horizontal line always. The axis of symmetry, I'm going to add of symmetry here. So the axis of symmetry for this type is going to be the y-axis. we have two other pieces of information we're going to be dealing with too in our work today. It's going to be focal length and focal width. The focal length is always going to be our P, and the focal width is always going to be the absolute value of 4P. Okay? Now on the right hand side of this chart, this is the other type. We can write this as either y squared equals 4px, or we can write it as 1 over 4p equals x, y squared equals x. So if this is a parabola that has x linear and the y is squared, then it's going to be a parabola that opens to the right or left. Okay, just like up and down, if it's positive, it's going to open to the right. Negative, it's going to open to the left. The focus is always going to be at P0. The directrix, you notice this time, is a vertical line, as you should suspect, since if we have a parabola that opens to the right, let's say, for instance, okay, and the focus is over here, and the directrix is over here, the directrix had better be perpendicular to the line that connects the focus and the vertex. So focus, vertex, directrix this time is a vertical line, and hence the equation is x equals negative p. The axis of symmetry, of course, is the x-axis. Focal length and focal width are the same. Okay. Alright, so here's a picture of the sideways version. Okay, as we should expect, almost the same information as the up and down version. Okay, and again, all in that chart nicely. So let's see what happens if we're asked to write an equation for a parabola given some information. So we have a parabola, we have the directrix whose line is x equals 3. Focus is the point negative 3, 0. What I like to do before I start any problem like this is draw a picture of the information we're given. Okay, we know that the focus is at negative 3, 0. Okay, that's right there. We know that the directrix is the line x equals 3, which is right here. Okay, and automatically that tells us that the vertex is right here in the middle of those two. So we do have a parabola that opens at the origin. If the directrix is over here to the right of the focus, that means that in some capacity we're going to have a parabola that opens to the left. And again, I'm just roughly drawing that. We could plot some points after we write the equation to get a better graph of it. But ultimately our key piece of information here is which way does it open, because that leads us to the fact that we're going to be using the 4p y squared equals 1 over 4p y squared equals x version, or we can write it as y squared equals 4px, either way. Okay, so let's see on the next slide how they handled that situation, because ultimately we need that value of p if we're going to write the equation. Okay, so the directrix is x equals 3, focus is that. The focal length is negative 3, okay, because ultimately the focal length is going to be the distance from the origin, or excuse me, the origin in this case, because it's the vertex, to the focus, which is going to be negative 3, because we're going left. The parabola opens to the left, we know, and so therefore if we plug in the p-value that we have here, we're going to have negative 12x. So we could either write it as y squared equals negative 12x, or I usually write it as 1/12 y squared equals x. Have the variable that's linear solved for. So either one of these is fine. Okay, we can do it either way we choose. All right. So again, that focal length is the distance from the vertex to the focus. Okay. All right. Now, what happens if we have a parabola, like in a lot of cases, the parabola is not going to open at the origin? Okay, we might have a vertex at a different point. So the translated versions of all of the formulas that we looked at in the first part are here on this slide. Notice that all we're doing is if we move the vertex to hk, it's x minus h, y minus k. Exactly the same thing that we did with our translations that we've been studying the entire year. Okay, so that shouldn't be terribly surprising. And again, all the other points and lines get translated as such. Okay, just like we would translate the equation. Okay, so taking a look at this next one, I asked us to write a standard form equation with a vertex at 1, 2, and a focus at 1, negative 2. So once again, I would draw myself a rough graph to get an idea of what my equation is going to be like. If I go 1, 2 for my vertex, and then 1, negative 2 for my focus. So this is vertex, this is focus. That means my directrix is going to be 1, 2, 3, 4 above. So here's my directrix, and then I know that this is going to open down. Okay, and again, just a crappy graph, but ultimately just want to know what it's going to open like so that I can go back and start with the correct equation. If it opens up or down, going back to our previous slide, we're going to be using this version. So I would write down x minus h squared equals 4p y minus k. Okay, so write down the correct version. Knowing that the vertex is here, the focus is here, means that, knowing that the vertex is at 1, 2, gives us h and k. So we can write x minus 1 in our parentheses, and we can write y minus 2 in our parentheses. And the only other issue is we need to figure out what p is, and then we'll be complete. So if we look at the next slide here, okay, again, hk is 1, 2, that's our vertex, okay, and the distance between the vertex and the focus is 4, okay, and so therefore we're going to put in 4. Keep in mind it's negative because it opens down, and remember 4 times 4 of course is 16, and so to finish it out we would figure out our p-value, plug it in, okay, and we will get our final equation. As you can see, going back to the drawing, remember this time we're opening down. Anytime we're opening either down or left, that p-value is going to be negative. The distance from vertex to focus, of course, is that p-value 4. And again, it's negative because it opens down. Anything left and down, that p-value will be negative. Anything opens right or up, the p-value will be positive, which again makes that leading coefficient positive as well. Okay. Alright, so the homework that we're going to work on today is going to be mainly regarding parabolas. Okay, and we'll go ahead and get started.